Hello, students, and welcome to Calculus in 10 Minutes or Less. Today, we're going to review the product rule. I have an example here from the OpenStax Calculus Volume 1. This is Section 3.3, Example 3.24. And then, of course, above here at the top, I have the statement of the product rule. Recall that if we are differentiating the products of two functions f and g, we must find the derivative of f and the derivative of g, and then multiply f times the derivative of g and add g times the derivative of f. So let's complete this example in 10 minutes or less. Applying the product rule to binomials. Here we are given a function j of x that is a binomial, the product of two binomials, actually. And we are asked to find j prime of x. So when we are asked to find j prime of x, we will write it like this, and we will differentiate j of x. So I'm going to pick up this function j of x, and I'm going to put it right here inside that derivative operation. So we are going to take the derivative of a function x squared plus 2 times another function 3x cubed minus 5x. And this is hopefully when you will start to recognize that you need the product rule. You have a function here multiplied by another function here. And when you're doing these product and quotient rules, I highly recommend that just below the function you're differentiating, you write down the expressions. And you notice that I use colors because I think it helps illustrate these concepts a little bit better, especially if you're learning them for the first time. Then write down their derivatives. When we differentiate x squared plus 2, we need the power rule here, and the derivative of a constant is 0. So the first function, 2 or x squared, has a derivative of 2x. The second function has a derivative of 0, but generally when we have plus 0, we just don't write it. Then next, we have the derivative of 3x cubed minus 5x. This is another product rule, 9x squared minus 5. Go back and review that product rule if you need to. Now we have all the pieces we need to apply our product rule formula. And when you're doing these examples, I highly recommend that you write down the product rule as you are applying it. So we are finding j prime by applying this product rule. And it's right there to help us out if we rewrite it. Or in my case, I'm doing this in 10 minutes or less, so I am going to copy and paste. I need the function f, which is right here, and I need to multiply that by the function g prime. That's the function in orange. And when you're dealing with polynomials, or really just in general, it's not a bad idea to write the expressions together, put them in parentheses, and worry about multiplying them out later. I encourage you to get something written on your paper before you stress too much about what comes next. Next, we add g. This is the green function. That's why I picked green, because it starts with g. And f prime, which is colored in purple. And then, of course, we do want to simplify the algebra. And in this case, we have some foiling to do. We need to multiply x squared by 9x squared. That's 9x to the fourth. Then we multiply x squared times negative 5. Then we multiply 2 times 9x squared. And then finally, negative 5 times 2. Then we're going to add, and this isn't a foiling problem because we only have one thing in this sum. Here we had a sum of two expressions, x squared plus 2. Here we don't have a sum. We just have a product of 2x. So we're going to kind of distribute that 2x into the sum in green here, even though it's on the right. A lot of times you see this written with the thing you want to distribute in this case, the 2x on the left, but that's okay. We're going to do 2x times 3x cubed. That's 6x to the fourth. And then we're going to do 2x times minus 5x. That's minus 10x squared. And then we are going to combine it. We've got 9x to the fourth. And then we have some x squared terms here and here. We have minus 5 minus 10, which is minus 15, and then we have 18. So we have a total of 3 of those left over. And then, oh, I missed a combination. 9x to the fourth plus 6x to the fourth. So the coefficient in front of x to the fourth is actually 15. And then we have left just minus 10. That doesn't combine with anything. Now, this problem statement does ask that we check the result by first finding the product and then differentiating. So what that means is take our original expression that is in the derivative operation. And again, we're still finding j prime, but what we're going to do, instead of assigning a function f and a function g, is we're going to FOIL first. When we do so, we're going to obtain a sum of 4 things that we might be able to combine. But in this case, instead of needing to assign f and g for the product rule, we are going to be able to just differentiate it using the power rule. So we have 3x to the fifth minus 5x to the third plus 6x cubed minus 10x. And again, now we can just apply this derivative rule. We've got constant multiple rules, difference rules, and sum rules here. The derivative of this is 15x to the fourth minus 15x squared plus 18x squared minus 10. And you can see we combine negative 15 and 18, again, just like we did up here, negative 5 minus 10x squared plus 18x squared. So this is 15x to the fourth plus 3x squared minus 10, which is what we saw here.